In the next few videos, we want to find and classify critical points. So we're going to use something called the first derivative test, and it's based on a very simple idea. So suppose we have, say, a local minimum. What is a local minimum? Well, it's where the function has been decreasing, and then the function increases. Now, in terms of the derivative, we can understand decreasing as having a negative first derivative. And then in this case, we have 0 when the function bottoms out. That's when we have our local minimum. And then after that, the function increases, which means that the derivative is positive. So a local minimum can be characterized by having a negative first derivative followed by a positive first derivative. To the left of the critical point, we're negative. To the right, we're positive. Same sort of analysis applies to local maxima. Here's a local maximum. It occurs right here. Before this critical point, the function's increasing, so the derivative is positive. Then it's 0 here, where we have a horizontal tangent line, and then it decreases. Decreasing in terms of the derivative means negative. So in terms of the derivative, we can figure out whether we have a local max or a local min based on whether to the left and right we have negative or positive first derivative. If we have negative followed by positive, that means we're going to have a local minimum. If the derivative to the left of our critical point is positive followed by negative, then we have a local maximum. Okay, so this simple idea gives us a way of testing critical points for whether they're local maxima or minima. Let's look at a summary of this test. Here's the first derivative test. The first thing we want to do is actually find the critical points. So once you find the critical points, for each critical point, check the sign of the derivative to the left and to the right. If it's plus followed by minus, then it's a local maximum. If on the left it's negative and on the right it's positive, then it's a local minimum. And if you have plus plus or minus minus, it's neither. In this case, the function's always increasing. In this case, the function's always decreasing, so you don't have a max or a min. Let's use this in an example. Here I have the graph of the function f prime. Now it's important to note this is not f, this is the graph of the derivative. But I want to find and classify the critical points of the original function f. So when I look for critical points, I'm not looking for horizontal tangent lines to this graph. I'm looking where f prime is 0, or it's undefined. Where is f prime 0? F prime is 0 here at 3, it's 0 at 5, and it's 0 at 7. So those are going to be my critical points. It could also be, a critical point can also be a place where the derivative doesn't exist, but the derivative always exists for this particular function. There are no kinks in the curve. So there are my 3 critical points. Now I want to classify each of these critical points. So for the first critical point at 3, I check the derivative to the left and to the right. That's the first derivative test. To the left, the derivative is negative because the graph of the derivative is below the x-axis. So I start with negative. And then to the right of 3, my critical point, f prime is now positive because the graph of f prime is above the x-axis. So it's positive here. So I have a minus followed by a plus. In terms of the first derivative test, that tells me I have a local minimum, minus followed by plus. So I write local minimum corresponding to 3. X equals 3 is a local minimum. Go into the next critical point at 5. Well, before 5, the graph is above, so I have a positive first derivative. After 5, the first derivative dips below the x-axis, so it's now negative. That is, I have plus on the left, minus on the right. According to the first derivative test, plus followed by minus is a local maximum. So this point at 5, x equals 5, is a local maximum. The last critical point here is at 7. Before 7, f prime is negative because the graph of f prime is below the x-axis. After 7, the graph of f prime still stays below the x-axis, so it's still negative. Notice it never crosses above, so it's negative before and after. So according to the first derivative test, I'm in the case of negative, negative, so it's neither local maximum nor local minimum. So the f at x equals 7, neither local maximum or min. So I have 3 critical points. Only these two are extrema. This one's not.